Hello, this is ldmicro. Today, I'm going to show you how to use LCD with ldmicro. We are going to use liquid crystal LCD 1602. Also, we can use LCD 2004, but in this case, we will be using 1602 liquid crystal. Before starting, I will attach a link in description below. That link contains a circuit diagram that you have to implement. This circuit works as an interface between your LCD and your microcontroller. I will explain the details of the link below later. First, we have to implement the circuit. Okay, this is the web page from link below. First, we go to Wiki. In this part, we type LCD, then, we click on second option. Here it says we can use Hitachi LCD and other ones too. Here there are the commands that we can use to interact with LCD. This is the important part, the circuit diagram, but this one is for working with the computer. This is the one that we have to implement in order to communicate the LCD with the microcontroller. As you can see, the interface is just another microcontroller. In this case, a 16F628 microcontroller. For now, we won't be using these push buttons. They are optional. They work with transmission pin from this PIC16. These transistor and resistor are optional. They work for LCD backlight. I have made the circuit diagram a little smaller. It works okay too. I could make another video using the push buttons, but for now, we are going to learn a basic LCD tutorial and we have to implement this circuit first. Attention, very important message, we have to save the hex file located here, to the PIC16F628A. In order to work as an interface, if you don't do that, your LCD won't work. Okay, I have already implemented the circuit here. How do you know you did okay? Well, if you have already saved the hex file downloaded before into PIC16F628A, this message should appear after energizing the circuit. This is the creator's name. By doing this, your PIC16F628A will be able to translate ldmicro serial instruction to the LCD 1602. We'll use matrix orbital commands. Now, we have to make a ladder program to print values in LCD. However, you may not know it, but there are several ldmicro versions. So, which version can we use? According to my research, I hope there is no mistake, otherwise let me know. There are 3 ldmicro versions that I consider they work okay. We have the official 2.3 ldmicro version created by Jonathan Westhuse. However, in this version, we cannot use Arduino Uno. Also, there is a bug that I will show you right now. If we select Uart string instruction, that will print values on the LCD. And then, we make an open circuit condition. String should not print anything, because there is an open circuit. But, if we simulate the ladder logic, it shows us that values was printed. This should not happen. But it is okay for practicing, even for LCD if you are beginning with ladder logic. You can download the official 2.3 version from the ldmicro website. In this part, you can download your language version. There is the unofficial ldmicro version that Jonathan, the original creator, sponsors. This is the upgraded ldmicro version made by Ihor Nehrutsa. He has been upgrading ldmicro since 2016. If you notice, it is Ihor Nehrutsa that designed this GitHub repository that contains the circuit diagram that I showed you at the beginning of this video. He has also made other tutorials inside his GitHub repository. Have a look at them. He has added many microcontrollers, for example, Arduino Mega and Arduino Uno. He has also fixed the 2.3 ldmicro bug. As you can see, if we simulate, the ladder logic is fulfilled. You can download latest version from description below in releases option. Well, last but not least, José GUILLES 2.4 version. The origin of this version is a little curious. It was made by José to fix the 2.3 ldmicro official version bug. He hadn't noticed that Ihor Nehrutsa had already fixed the bug. You can download José's 2.4 ldmicro version from link below. It is available in many languages too. In this version José added Arduino Uno. As I said, he fixed ldmicro 2.3 version bug too. Ladder logic is also fulfilled if we simulate. You can practice with this version too, it is okay for beginners. I have to mention that thanks to José, Ihor Nehrutsa's ldmicro contains A2C and ASPI instructions, but this stuff is for another video. Okay. Let's do our first ladder that will print a value on the LCD, in this case a counter. I will use 2.4 ldmicro version, you can use Advanced Ihor Nehrutsa's version 2. This is a ladder program that counts in a loop up to 4. You can make also your own counter. The advantage of the ldmicro, in my opinion, is its intuitive logic. For printing the counter, we have to go to list commands that I showed you at the beginning of this video, the matrix orbital commands. It says that we have to use 254 decimal command first to access the other commands functions. We have to use hexadecimal conversion list for ldmicro. 254 is FE in hexadecimal. Okay, we add a delay to wait LCD loading time. Then, we add Uart instruction. This instruction will print a value on the LCD. Important, here we add the value that we want to print, in this case a counter value named C1. Here we add the commands. As I said, we have to begin with decimal number 254. 254 conversion to hexadecimals FE. Then, we can access to position command, decimal number 71, column and row, where we can print our counter value. 71 to hexadecimals 47. We add column and row. Also we add number 1 because our counter is a one-digit number. If counter number were up to 10 or 20 we should add number 2 because it would be a two-digit number. we configure a microcontroller. In my case I am using a 20 MHz crystal and set baud rate to 9600. I will use 16F877 a microcontroller. You can use a Mega too. We save and then we compile. Transmission pin of your microcontroller must be connected to 16F628 a receptor pin. Also both microcontrollers' ground pin must be connected. Let's save heads file to our microcontroller. As you can see, it only counts up to number 2. I wanted to show you this. In order to mention that, you must set constantly the counter number. We can fix it like this. You know that counter number is every 1 second, so we can use the time as an oscillator to send counter number each second through Uart instruction. We will be sending, every 1 second the counter number, to the LCD. Let's compile and test again. We can see that counter number value now. Before making the fix, the microcontroller was counting the number, but not sending it. We are going to delete those weird values now. In command list we can see that for cleaning the LCD, we must use decimal number 88. 88 to hexadecimal value is 58. So, we are going to make an easy fix. We are going to clean the LCD screen first. I am going to move the delay timer here. In order to activate clean command first. We add a rising edge to clean LCD screen just once. If we don't add a rising edge function, command would be cleaning the LCD screen constantly. We are going to use clean command here. Remember to use FE first, to access clean command. Then, I will use falling edge instruction. Important, if you would like to activate something with Uart instruction, just use falling edge. In my case I will activate a set coil instruction. In order to clean LCD screen first, and then the counter number begins, that is, first clean the screen, and after that, print the counter number on the LCD. Okay, let's test it. As you can see, first we clean LCD screen, then, we print value. This is a simple counter number. You can notice that the challenge is programming the LCD. But don't worry, practice makes perfect. It is important to underline that this is not the only logic to print values. You can try your own logic. I just showed you the icing on the cake. This ladder logic, for example, it shows 3 parameters on LCD screen: temperature, clock and counter number. The LCD programming is a little bit, however, as I told you, try your own ladder logic and most important, practice. And you will be able to make this. I recommend you to build or get some kind of training platform. I had to make my own one. It looks a little awful, but I can program with my CSP connection, so I don't have to disconnect the microcontroller or build the LCD interface every time I want to program a ladder logic. Same example here. Decimal numbers with some fix. Potentiometer value. It is important to underline, if we compile same example with both 2.4 and 5.3.0.1 version, Ihor Nehrutsa's version uses less space memory. As you can see, ldmicro growth is made also by its community, by reporting bugs, suggesting good ideas, helping other members. So, if you have any doubt or problem, just ask in ldmicro forum. Maybe I can help you. I know this video was too long, but I wanted you to know a little more about ldmicro. Maybe someone can make a new smaller video. Well, that's all for now. This was ldmicro. See you next time.